Hi there, fourth period. This is Miss Backfish, and I am taping this or recording this right after your class. And I'm recording it mainly because I'm sad. You're probably sad too. The reason we're both sad is that I did a poor job of teaching you today's lesson, and I apologize for that. How sad are we? Well, we're maybe this sad, or this sad, or possibly even this sad. Let me tell you how I did a poor job and why I did a poor job. The reason why I did a poor job is something that I've actually cautioned you against quite a bit, and that is when something seems too easy, we have a tendency not to pay much attention to it and not give it its due, and that's when we can make mistakes. And so in looking at today's lesson, this is something that you already know how to do, and I'll show you in just a second how you already know how to do it. This is something that I know should be very easy for you. And so instead of just, as I was actually going to give you a PowerPoint, I decided that a PowerPoint presentation and notes and everything was kind of boring and we should do an activity. Unfortunately, by the time I decided this, it was so late in my planning period that when I found what is really a good activity, and we're going to go ahead and conclude that activity tomorrow, I did not attend carefully enough to it and realize that it had so much inverse variation. I thought the only inverse variation it talked about was just, is it direct or is it inverse? And if you know what direct is, then you can tell it's not direct or if it is direct. And so I really thought that was the only extent to which you would need to know inverse, and no, it really gets a lot more into it than that. So hopefully we're going to move forward from that and get very happy. And I want you to be happy by the time you finish doing your homework tonight so that when you come in tomorrow we can go ahead and conclude that activity very successfully. You could even be joyful, in fact. See, I wanted to make sure you knew exactly how happy you can and should be about direct variation. So I told you direct variation is easy. This is how easy it actually is. A direct variation function is really nothing more than a linear function, which is something you already know about, that has a positive slope, which is kind of like the easiest slope maybe, and passes through the origin. So it kind of has the easiest y-intercept. So this is a very simple linear equation. That's what a direct variation function is. It's a linear function that has very simple properties, so to speak, a positive slope and a y-intercept that's the origin. So that makes the equation very simple. It's basically just going to be y equals some number times x. Now this is basically what was on the board. I elaborated a little bit. Oh, excuse me. There we go. This is basically what was on the board at the beginning of class. But I didn't, instead of taking a screenshot because somebody ran their finger through it for some reason. I know somebody's out there giggling right now. I went ahead and typed it up again, and I'm not sure exactly how I put it when I put it on the board the first time. So the value of the dependent variable changes directly with the value of the independent variable. That means basically there's no y-intercept other than 0. It's not my dependent variable is the independent variable times 2 plus something or minus something. It's just the independent times 2 or just the independent times 4. Okay, if x is increasing, so is y. Direct variation is always linear, always linear. The slope of the line can be called the constant of variation, or also sometimes it's the constant of proportionality. And the equation is y equals kx. So that's kind of like y equals mx plus b. Your m is your k. In other words, the constant of variation is the slope. So your m is called k for constant of variation. And there's no y-intercept because it's 0. It always passes through the origin. Okay, so that's pretty much all as we were saying in class. Excuse me. But let's look at inverse variation and contrast. Okay, the contrast that with inverse variation here, the value of the dependent variable changes inversely, not directly, with the value of the independent variable. If x is increasing, y is decreasing. Excuse me, we're not relieved yet. And the direct variation is never linear, okay? Let's look at the equation. It's right down here. Y equals, and this is not pretty. I'm pulling out of this. Hang on. One sec. I had it as nice bullets. Why am I doing this? That is not what I wanted to do. This is what I wanted to do. Here we go. So as bullets, if x is increasing, y is decreasing. So that's one thing that makes inverse different. It's never linear. Let's look at the equation. It's right down here. Okay. Okay, here's the equation. It's weird highlighting over here. Y equals k over x. That can't be linear because you have x to the negative 1 power. Okay, so that's by definition not a linear function. So y equals k over x, it's not going to ever be linear. There's still a constant of variation or constant proportionality, k, but here's how it fits into the equation. It's not k times x, it's k divided by x. And as a result, it never passes through the origin. Think about if I tried to put a 0 here, a 0 here, 0, 0, the origin. 0 equals k divided by 0. You can't have a 0x value in this equation because it would be undefined. So it's not going to pass through the origin ever, ever. Now, back to our little PowerPoint, or actually, let me just skip the PowerPoint. And let me show you, there are a couple of places that you can get a little bit more info if you'd like it. Here. Let's go ahead and if you want some more information on direct variation or inverse variation, direct variation, go either one actually. Go to Google, type this in, and the very first result you will get, Regents Exam Prep Center. That should be true for both of them. The very first result you should get either way is Regents Exam Prep Center. And it has a really good description for both of them. Here's the one for direct variation. There's my line. It goes through the origin. Here's inverse variation. Okay, let me see if I can scroll over. I don't know that I can. There we go. Okay, so here's the one for inverse variation. Notice it's got 2 points charted here because to find out what k is, sometimes you need to plug in a point. The example they have here is if you have a bike and it's traveling 8 miles an hour, it's covering 8 miles in 1 hour. But if the speed decreases to 4 miles an hour, it's going to take the biker 2 hours, which is an increase in time. So as his speed decreases, the time increases. Okay, so speed, this is miles per hour, that's decreasing. Time that it takes him is increasing. So that would be an inverse variation relationship. Let's see. This is an example of finding the the constant of proportionality, plugging in one ordered pair. If you know that this situation is inversely related, you can take x and y. No, I'm sorry, that's the other way around. Here is your y, and here's your x, and plug them in. And find out what k would be. It really doesn't matter which way you plug it in. And same thing here. If you want to find another value, you have to find k. So if you want to find k for an inverse variation, this is still really what you need, that equation right there. If you want to find k, you find an ordered pair and plug it in and see what k would be. And then it's the same k for anything in the same situation. Any of the ordered pairs in the same situation would fit into that equation with the same k. So there's no inverse variation on your homework. That's probably, maybe that's the relief. But tomorrow we'll go ahead and go back to this activity, and we will go ahead and do all the inverse variation problems in this. Because inverse variation really isn't that hard. It's just that I didn't realize much of it was in there, and so we really didn't address it. So hopefully this is a relief to you, and you should be able to do your math homework tonight very easily, just because it's just a linear equation that has a y-intercept of 0 and a positive slope. That's all you're dealing with tonight in homework. And tomorrow we'll discuss it further. Thanks for your patience. Bye.